Hi, I'm Maria Kuptsova. I'm doctoral candidate and research associate at the Synthetic Landscape Lab, Institute of Urban Design at the University of Innsbruck. I work under the supervision of Professor Claudia Pasquera. I'm going to introduce you my research biotechnique, implementation of synthetic intelligence into design protocols. Today, the Earth and the cosmos have been transformed into a gigantic technological system. The concept of nature is changed, evolving its meaning from a romantic Garden of Eden to a cyberganic form of living, understood as a natural technical continuum. Non-human agencies as machining algorithms, transgenic plants, and planetary viruses are equal actors within the hybrid reality we live in. The technosphere is included in ecological thinking. Technology embedded in the multiple objects within the landscape allows new regimes and metabolism to evolve. Through sensors and intelligent technologies, we are decoding the complexity of flows, behaviors, and patterns embedded within the landscape. We see a strong potential for an explosion of new design methods, taking form through synthetic biology and artificial intelligence. However, contemporary design computation is still centered around human and structured by our prejudice. Can we develop a design technique that could shape a new form of communication between human and non-human, replacing the anthropocentric approach with the design of cyberganic living systems? Biological organisms are operating with its own biases and mode of reasoning. The behavioral model of fungus, bacteria, insects, and animals can be understood as a form of intelligence which acts within the alien for us realm. Stratum of the landscape encodes and stores knowledge about the microclimates, microchemical compositions, and multi-species interactions. Machinic intelligence has its capacities to search, generate, and process information with an efficiency non-comparable with human capacities. We could consider machine learning as an instrument of knowledge magnification that helps to perceive features, patterns, and correlations through vast spaces of data beyond human reach. What if the intelligence of an organic system could become an input to a technological system with its own evolutionary algorithm? In this case, biological models could frame new biases for the machinic operations. The conversation between biological and technological systems would frame a meta-language, which can be considered as a synthetic form of intelligence. In order to propose a biodigital design system, my research is focused on a timber structure. Traditionally, architectural material has been classified as either structural or functional. In a natural system, it is difficult to differ between structural and functional materials. Biological matter is heterogeneous and informed through the direct relationship with the environment. Wood is widely used in architectural construction because of its mechanical, environmental, acoustic, elastic, hygroscopic, thermal, and aesthetic properties. However, the heterogeneous properties possessed by wood in its living state are usually considered to be rather problematic. To study the material organization of wood, the project uses a large database on the botanical characteristics of different wood species developed by the ArchiWood project. Microimages of about 1,000 species were collected and analyzed with different contrasting techniques in 3 anatomical cuts and in 3 different magnifications. The distribution of vessels and fibers indicates varied degrees of densities and porosities, as well as reveals the heterogeneous anisotropic properties of wood. These qualities, which are usually considered as a negative side effect, can be rethought and reused in a design of artificially alive systems. The research proposes the use of generative adversarial networks as a method for extracting these material organizational principles from an existing database of timber structure. Style 2 variant of GAN was chosen as the most studied in architecture. During the training process, GAN architecture forms a latent space, which can be imagined as a space of network's knowledge. A series of points can be created on a linear path between 2 points in the latent space to set up a latent vector. To visualize the internal and external morphology, the latent vector interpolation was translated into z-axis of a volumetric structure. In this process, the basic geometrical data describing the anatomical properties of a timber structure were extracted. This network of curves and surfaces describes the distribution of material as a behavioral pattern. A volumetric model is formed based on a point cloud data generated from transverse timber structure cuts. Fabrication technologies, such as additive manufacturing, allows for the development of adaptive fabrication methods informed by research in material behavior. Wooden-based filament is used as a 3D printing material, suggesting a new regenerative life cycle of matter from the wood in its living state to recycled wooden material. Material studies provide a new insight on how additive manufacturing can be used to develop novel approaches for timber construction. The use of a large-scale industrial 3D printer, VASP, allows the material experimentation at a larger scale. However, in the next steps, multi-scalar robotic system will be implemented as a fabrication method. This would make digital fabrication techniques available at even larger scale, as well as would set up a direct relationship of the fabrication methods with environmental conditions. Additive manufacturing, regenerative life cycle of matter, as well as introduction of machine learning-based design technique, suggest the scenarios where cyberganic wooden structure could be artificially grown by the means of intelligent technologies. It challenges the process of growth, decay, and ontogenesis, introducing a form of cyberganic living object, which become a part of synthetic landscape choreography. This project aims at establishing a design strategy which places biological intelligence into its basis, as well as points towards the possibility of reshaping the human-centered approach in the design computation. Thank you.